Find the bearing of line segment CD. In this problem, points A, B, C, and D form a closed traverse. The problem statement provides the azimuth of line AB, and we're also provided the measured deflection angles at all 4 points in degrees, minutes, seconds format. These angles were measured using a device that can be measured down to the nearest 5 seconds in precision. In the provided data table, point A is repeated, so it is clear that the course leaving point D is headed for point A. The measured deflection angle at a point refers to the angle an observer needs to rotate to be aligned with the next course of the traverse. If the angle is in a clockwise direction, it is called a right deflection. If it is counterclockwise direction, it is called a left deflection. As an example, the deflection angle at point C deflects to the right by 75 degrees, 5 minutes, 15 seconds. All deflection angles given in the problem statement are right deflection angles, since traverse A, B, C, D progresses in the clockwise direction. To begin, we'll confirm the sum of the measured deflection angles equals 360 degrees, and make adjustments if necessary. The actual sum of these 4 angles equals 360 degrees, 0 minutes, and 20 seconds. This means the sum of the deflection angles over-rotated by 20 seconds. Since the angle measuring device only measures to the nearest 5 seconds, we'll subtract 5 seconds from each of the 4 angle measurements so that the sum of these adjusted angles equals 360 degrees, even. Next, we'll use these adjusted deflection angle values to calculate the bearing of line segment CD. To find the bearing of line segment CD, we'll first determine the azimuth of line segment CD, and then convert that azimuth to a bearing, which we'll designate as B sub CD. We can compute the azimuth of line segment CD by adding the azimuth of line segment AB to the adjusted deflection angles at points B and C. To better explain this calculation, we'll re-examine the traverse. From the problem statement, we know the azimuth of course AB equals 89 degrees, 36 minutes, 20 seconds. We also know the adjusted deflection angle at point B equals 156 degrees, 42 minutes, 45 seconds. The sum of these two values equals the azimuth of course BC, which equals 246 degrees, 39 minutes, 5 seconds. To find the azimuth of course CD, we'll add the azimuth of course BC to the adjusted deflection angle at point C. This makes the azimuth of course CD equal to 321 degrees, 45 minutes, 15 seconds. The bearing of course CD will be in the northward direction, with the deflection angle to the west. This unknown deflection equals 360 degrees minus the azimuth of course CD. Plugging in the azimuth of course CD, the bearing of course CD equals north 38 degrees 15 minutes 45 seconds west. When reviewing the possible solutions, the answer is C.